So today we are going to learn switching. Your routing is over, your access list is over. So today it's switching. Sorry. Okay. Today first we are going to learn what is VLAN. What is VLAN? Virtual Local Area Network. What is Virtual Local Area Network? You don't know. That is VLAN. Oh, wow. Very good. See, VLAN is an important concept. Okay. In simple, I will say it is a logical segregation of broadcast domain. Logical segregation of broadcast domain. First row is waiting for you. Logical segregation of broadcast domain. Okay. In simple, you can say this. See, why we require this VLAN is it is more secure. Okay. Easy to manage. Less bandwidth. And more speed, that is latency. So multiple reasons are there. Okay. See how this VLAN is going to work. The name itself it says virtual local area network. Correct. What is a local area network? That is within the building. Correct. See, I am having a router. Okay. Connected with a switch like this. Yes, please. Excuse me, guys. All right. So listen. Last bench. Okay. So I'm having a router. I'm having a switch. And another. So 6 PCs are there. PC 1, 2, 3, 4, 5, 6. Okay. For initially, if there is a broadcast packet coming in. Okay. A packet is coming in. What it will happen? It will come to the switch. Correct. And what the switch will do? It will broadcast. Nice. Is it nice? I don't need switch. So it comes to switch and the switch will send it to 1, 2, 3, 4, 5, and 6. I'll deal you later. Okay. It will come to each and everything so that the traffic will go to every pieces which are connected to switch. Correct, Dinesh? Correct. See, the reason I gave sweet is because this side I somewhere feel they will sleep because AC is there. So eat sweet, what will happen? You will have that little bit of, that caffeine kind of thing so that you will not sleep. That's why. Yeah. Okay. So the packet will go to each and every PC. For example, if I want that message to be gone to only one and PC 2. Okay. But the message will go to each and everything. It will go to 1, 2, 3, 4, 5, and 6. Correct. So what we are going to do is we are breaking the LAN into a multiple LAN. So this itself is a LAN network. Correct. Which are locally segregated. That is, we are connected to a private network and that is called your local area network. I'm going to divide that local area network into multiple small networks. For example, this 1 and 2, I'm going to say VLAN 10. This 3 and 4, I'm saying VLAN 20, and 5 and 6, I'm saying VLAN 30. So in this packet, I will say send it to VLAN 10. So that the packet will go only to 1 and 2, not 3, 4, 5, 6. Though they are in the same network, the packet will not go there. So we can say in simple words, see, VLAN has big definition. In PPT, it is there, I will show you. But in simple understanding, it is a logical segregation of broadcast domain. You should be able to tell this word and explain it. If you explain this, then they will understand, okay, you know what is VLAN. Okay. So there are multiple reasons. If I am going to do that, it is more secure. So that the 3, 4, 5, 6 PCs, which they don't want to get the information, they will not get it. So that it is more secure. Only PC 1 and 2 is getting it. Correct. And easy to manage. Correct. I don't want to send the packet to all the devices connected in the network and I have to verify it. No, that is not required. Only the intended person will get it. And that is easy to manage for me. For example, in a building, you have 3 floors. So, is it required that every HR should sit in first floor? Every sales should sit in second floor? Every IT should sit in third floor? No, right? So, they'll be mixed up. So, in first floor, you will have HR, sales, IT. Same likewise, HR, sales, IT. HR, sales, and IT. So, this HR, I will put everyone under VLAN 10. IT, I will put at 30. Okay, and sales at 20. Sales 20. So that even though they are in same floor, the message which is sent by HR team will go to only HR team, not the sales team. And the sales team, they are giving the sales, the numbers, everything will remain within the sales team. So how we are segregating it? Through your VLANs. Okay, so whenever there is a switch, under the switch, I will say this interface belongs to this VLAN, so that the other VLAN will not be able to access this as long as I send it to that intended person. So this is how your VLAN works. And this is the use of VLAN. Okay, now come to your PPT. First of all, switching, what is switch? It is a layer 2 device, intelligent device, which we have already shown. Broadcast domain, collision domain. It is a full duplex, correct? No collision will happen here because per port collision domain is there. But single broadcast, because every time, I mean, for the first time, if the broadcast comes, it will distribute to each and everything. Okay, so single broadcast domain. What is a VLAN? Okay, so VLAN is a custom network which is created from one or more local area networks. See, one thing I said like this. I have a router. I have a switch. I have 2 PCs. Okay. Likewise, I have another router here. I have another switch. I'm having another PC like this. Okay. So in this scenario, this is a different network. This is a different network. Here it is a different network. So this is network 2, network 1, network 3. Okay. So here, this PC I'm saying VLAN 10. This is VLAN 20. Likewise, this is VLAN 10. This is VLAN 20. Like other network also, it is possible to create under the same VLAN. So this is a different network, 10.0 network. This is 11.0 network. Okay. But 10.1 and 11.1 can be under same VLAN. For example, like I said, HR sitting in different network, different floor will have a different Wi-Fi connected. Correct. So in the first floor, you'll be connected to a different Wi-Fi. So a different network, but they will be able to send the information to only that person, only the HR team. How? Through the VLAN. So even with multiple networks, it is possible. Whatever you connect, accordingly it will act. Okay. Okay. Now come to PPT. So it is a created for one or more local area networks. That means different networks. It enables a group of devices available in multiple networks to be combined into one logical network. That means if there are multiple devices, okay, in different network also, in our network also, we are making into a one logical network. That is VLAN. So if there are 5 networks, so 10.1, 11.1, 12.1, 13.1, and 14.1, and 15.1, I will put all those PCs into VLAN 10. So they will be acting as like a one network. Okay. So that is the use of VLAN. And then the result becomes a virtual LAN that is administered like a physical LAN. So under a physical LAN, it will become a virtual LAN. That is virtual local area network. Okay. And the full form is virtual local area network, which you already know. Okay. So now you have a clarity what is VLAN. Correct. You will simply not say it is a virtual local area network. Now you will be able to explain that. So to, reduce the bandwidth, we are making this VLAN so that the intended traffic will go to the particular systems, not the everywhere. So it is the logical segregation of your broadcast domain. Okay. Now come to the other point. So what will happen without VLAN? Without VLANs, a broadcast sent from a host can easily reach all network devices, correct? So if I send a broadcast packet, it will go to each and every devices in the network. Each and every device will process broadcast received frames because it will go through switch. So switch will understand frame and frame will be sent to each and every devices. So that we don't want. Okay. It can increase the CPU overhead on each device and reduce the overall network security. So I don't want to send the broadcast message to every employees that are connected in the network. No, I don't want that. I want to send to only the person who is authorized to send. Okay, so that's where we are using this VLAN. In case if you place interface on both switches into separate VLAN, a broadcast from host A can reach only devices available inside the same VLAN. Okay, even if it's within the network, within the local area network, there are 4 PCs. So first two PC in VLAN 10, other two PCs in VLAN 20. So 10 and 20 cannot communicate because they are in different VLAN. Okay. And host of other VLANs will not be even aware that the communication took place. So for example, if a broadcast packet is coming in and I'm sending it to VLAN 10, so the VLAN 20 will not even know that a packet came inside the network. So they are totally unaware of the broadcast packet. So that increases the overall security and reduces the CPU overhead. Okay. And here VLAN is a networking, is a virtual extension of LAN. A LAN is a group of computer. We have seen what is LAN already. LAN, man, can, we have seen that. So what is a VLAN? VLAN is networking, is a virtual extension of LAN. So if you're having multiple LANs, we are making it as virtual. How virtual? Because multiple devices we are making into a different VLAN. Under a LAN, we are having another VLAN. That is a VLAN. Any doubt? Offline? Everybody clear? What about online, guys? Okay, write down this VLAN range. Mhm. Recording, I didn't start. No, it is recording only. I again recorded. Pause recording, stop recording. It is recording. Thank you. Because sometimes I forgot to record and how many of you are local here, Bangalore? Any local? Bangalore. Ulla Bangalore. Stay Mattanam. Just asking if you're like from Bangalore. Step up. Step.
So just a doubt in this range. Here, the first one says 0 to 4095 is all reserved and which cannot be used, but then everything after that falls within that range, right?
No, no, no. I will explain you. This is not zero and here. You can add and.
Okay.
Okay. Okay. Roni is from Bangalore. Okay. After class, I'll talk to you. Excuse me. Your doubt is valid only. I think Prashant asked. It is and guys. 0 and 4095. Sorry. What's your name? I forgot. Hemant. I'm also watching you. I may feel sleep, but I can never sleep because I have to keep on talk. You don't have that advantage. You want to take class? Written? Everyone? All right. So we have a range of VLANs. Okay. First, initially, VLAN 1. This is your default VLAN. By default, all the interface of the switch belongs to this VLAN. Okay. By default, all the interface of a switch will belong to VLAN 1. And here you cannot delete this VLAN. This is always present in your switch. You cannot delete it, but you can edit this VLAN and you can be used. Edit as in you can change the name. Okay. Likewise, you can edit it, but you can't delete it. If a switch port is not in any other VLAN, it will be belong to default VLAN 1. As of now, we did not create any VLAN. Did we create any VLAN? No. So all the switch ports of the switch will belong to VLAN 1. That is the default VLAN. Okay. And then we have 2 to 1001. This is your normal VLAN range. Here you can edit, create and delete the VLAN. A new VLAN can be created. A name can be created, that is editing, or even you can change the name and you can delete the VLAN. You can add the switch ports. That is your normal VLAN range. And this is your extended VLAN range. Sorry, this is your extended VLAN range. 10062 4094. This is used in VTP version 3. VTP version 3, we are using this VLANs. Okay. This is your extended VLAN range. Here also you can add, delete and create. So here you have 10021, 1005. These four VLANs are, they say legacy VLAN. They say legacy VLANs. This we cannot delete, we cannot use nothing. This we are using in early stages for FDDI token ring, your bus topology, tree topology time. We are using these VLANs. Nowadays we don't use it, but we can't delete also. So this is a reserved VLAN. It will simply be in the switch only. Okay. Likewise, here you have 014095. These VLANs are used in virtual machine, like your VMware. Okay, there it is used. For virtual machines, we are using this VLAN. And zero, sometimes they are used for quality of service also. What is this quality of service? I will decide in, I will tell you in the uh, last class of your CCNA. What is this quality of service? Okay, so likewise, these two also reserved and you cannot use it. So where you can use it, 1 to 1001. This is the standard range you will be able to use the VLANs. Okay, you written this? Okay. Now important thing I will teach you. Access port and And applications and purpose of VLAN. So VLAN is used when you have more devices on your LAN. What is the maximum number of VLAN configured on switch? You can configure as many as you want. Within the range, you can configure how many VLANs you want. That is 221001 also you can configure. Okay. So we are having multiple switches, guys. Okay, we have that I will teach you in CCNP. Okay. We are having L2 switch, L3 switch, multi-layer switch. See, multi-layer switches are more than 1 crore. Okay. And where it is used means in aircraft carrier it is used. That is fighter jets. Okay, for path manipulation. It is very speed, high in speed. And you have almost 55 to 60 lakhs starting ranges for each switch. Okay, until 1 crore it is there.
Uh, is there any cyber students here? Cyber, cloud. Okay, I already informed you that you can take Linux. We have Linux on 21st, 2 p.m. to 4 p.m.
I don't think so online. Online, any cyber or cloud students? No,
Okay. Like when you'll be completing this batch?
I'm not sure yet. Probably next month, next week or the next week.
But 21st, before 21st, you will be completing, right? Because for him, we have Linux now, so that he can join.
Yeah.
Same batch, like 2 p.m. to 4 p.m. Okay. Then you want to explain you have the batch schedule.
Hmm?
Which one they have to take, like on 21st, before 21st?
No, I might. Actually, you. So you can create how much VLANs you want. Okay. And then applications. VLAN is used when you have more devices on your LAN. So if you are having 10 devices, then there is nothing much to, segregate the traffic. But if you have 500 PCs, in that case, you definitely need VLANs. Okay. And it is helpful when you have a lot of traffic on the LAN. VLAN is ideal when a group of users need more security or being slowed down by many broadcasts. So for example, if broadcast packet comes to a switch and if there are 500 devices connected, and it will go to all 500 devices. So that will take time, as we discussed. Correct? So reduce the time and bandwidth, we are segregating it. Same thing they've explained here. It is used when users are not on one broadcast domain also. That means even if they are in different network, we are able to segregate the traffic and make a single switch into multiple switches. So if we don't have this VLAN concept, then what should we do? We should have multiple switches. Correct? And then we need to connect to a single switch. So if I don't have VLAN concept, if I need 5 VLANs, then I need 5 L2 switches. And those 5 to L2 switch will be connected to another switch. So you can segregate the traffic. Correct? But with the help of VLAN concept, with one switch itself, you are able to do it. Cost effective also, easy to manage also. Okay. Then you have advantage of VLANs. Okay. So this PPT I'll share you whatever I explain, same thing they have given here. You can go through it. Okay. And important thing, what is a switch port? Okay. On network switch, the switch port is the physical opening where a data cable can be plugged in. Generally, switch ports are rectangular on 3 sides with V-shaped pointed. I showed you the switch, correct? In lab. So all the switches are connected with the data cable and console cable. So that port is called your switch port. So there are two ports. One is access port and other one is trunk port. So what is this trunk port and access port? I'll explain you. I'm having two switches. Okay. Switch 1 and switch 2. They are connected to each other. So here I have okay. So these two belongs to VLAN 10 and this also belongs to VLAN 10. Okay. So 4 PCs belongs to VLAN 10. Now, will they be able to communicate with each other? Yes, because they're all in the same VLANs. Okay. So by default, your switch will be in access port. By default, switches are in access port. Okay. If I want to send from this PC1 to PC4, I will be able to send the message, correct? Because they are in same VLAN. So access port means same VLAN, it will carry the traffic. Okay, for example, excuse me. If I'm having this one is VLAN 20, this is VLAN 20. So this is 10, this is 20. Again 10 and 20. So if I want to send that packet from PC1 to PC3, will I be able to send? Yes, because same VLAN. But will I be able to send from 10 to 20? No, because access port will send only same traffic. Same VLAN traffic it will forward. It will not forward the different VLAN traffic. If you want to send the different VLAN traffic, then you need to be in trunk port. Then the port should be made it as trunk. Okay. Now, if you made both the ports as trunk, then VLAN 10 to 20, you can send the packet, or 20 to 10, likewise you can send. See, this 10 to 10 access port is okay. 20 to 20 access port is okay. But between this 10 and 20, it is not possible. Likewise, from this 20 to 10 also, it is not possible. If you want to send to a different VLAN, then you need trunk port. Okay, I'll give you some theory notes. You can write it down. First, write it down for access port. It is a member of single VLAN only. It can forward traffic to single VLAN only. So by default, all ports of the which are access port. Write down this. Written. Okay. Now, so an access port connects to a network host with a single VLAN and manages data traffic for virtual network, because data can only go back and forward on the designated VLAN. An access port handle untagged Ethernet frames. What is this untagged? I'll tell you. A trunk port usually connects to another switch and it's able to interact with several VLANs. Okay. On a complex network with multiple VLANs, a trunk port manages data transfer to and fro with virtual networks. Okay. Whatever I explained with the diagram, same thing they were given in definition. Understand with the diagram, you will be able to understand the concept clearly. Okay. So now I'll show you the practicals. How to create a VLAN, access port, trunk port.
What is the meaning of first one? So by default member of all VLAN.
By default, member of all VLAN means any VLAN it will accept. From 1, 2, 3, 4, 5, 6, 7, 8 till 1001, it is a member of all the VLAN. Whereas access port is what? Only one VLAN. That is 10 means only 10. 1 means only 1. 4 means only 4. Okay, likewise, it is only one VLAN member. So it cannot be a by default member of all the VLANs, it cannot be. So that's why trunk port, you can communicate with any VLAN to any VLAN. So that's why it is a member of all VLAN.
By default, which port is the access port?
By default, access port. Every switch port is an access port. I'll show you, see. By default, every port is a access port only. See, you can use this layer 2 switch, that is 2960 series. All the practicals you'll be able to do it in the switch itself. Okay. Same like your router only. Go to CLI. Okay. Host name switch 1. Show. We have one command called show VLAN brief. Okay. If you give this command, you can see the switch ports which are in which VLAN. See here. All 24 ports are in which VLAN? By default, it is in VLAN 1. 1002, 3, 4, and 5 are called legacy VLANs or reserved VLANs. We cannot use it, but it will be there in your switch only. You can't use it because these were using for the ring and tree topology back then. Okay. Now we are not using this concept itself. That's why we have this VLAN concept now. Okay. So how do we create a VLAN? First, how do I create a VLAN? Very simple. Just say VLAN 10. Now VLAN 10 is created. Okay. If you want to give a name for it, just say name. I will say sales. Okay. Done. I will say do show VLAN brief. Now can you see there is a VLAN created 10? A name is what? Sales. Now I'll say I'll create another VLAN. I'll say VLAN 20. Okay. So I'm saying VLAN 20. Okay. I'll say do show VLAN brief. Now VLAN 20 is created. Did I create any name? No. So it will say it as VLAN 20. Likewise, you can create multiple VLANs. So how I've created the VLANs, but is the switch ports are in the VLAN 10 or 20? No. How I'm going to add the switch ports? Okay, that I'll show you. Say VLAN 10. Okay, switch port. Say interface F0/1. Okay, and say switch port access VLAN 10. Okay, now go say do show VLAN brief. In VLAN 10, you see F0/1. Okay, now if I want to add this F0/2 in this VLAN 20, then what I'll do? Interface F0/2 switch port access VLAN 20. Okay. Do show VLAN brief. Is there? Okay. Now, what? Doubt. Okay. So now I want 3, 4, 5, 6, 7, 8, 9, 10. This 8 interface I want in VLAN 30. Then what I can do? Interface I can say, first I have to create the VLAN. I'll say VLAN 30, I'll create it. Okay. After creating the VLAN, I will say interface F0/3, switch port access VLAN 30. Interface F0/4, switch port access VLAN 30. Likewise, 8 times I have to give. Correct? Instead of that, there is one kind of shortcut command. First create the VLAN. VLAN 30 I have created. Say interface range. Okay. F0/3 to 10. Enter. Switch port access VLAN 30. Now say do show VLAN brief. See, 3 to 10 is in VLAN 30. So if you want the range to be completely in one VLAN, you can use this range command. Interface range F0/3 to 10. This is another method. Now if I want 11, 15, 19 and say 20. 11, 15, 19, 20 I want in VLAN 40. So now I can't use the range. If I use the range, what will happen? Everything other than the between the ranges also will come into the picture. So what I'll do, but for that also there is one shortcut. I'll create VLAN 40. Okay. Same interface range F0/11. Correct. Comma F0/15. Comma F0/19. Comma F0/20. Okay. Say switch port access VLAN 40. 11, 15, 19, 20 is in those particular 40 VLAN. Likewise, you can create the VLANs. How do I delete a VLAN? Simply say no VLAN. If I want to delete this VLAN 40, I'll say no VLAN 40. VLAN 40 will not be there, but those switch ports are in VLAN 40. So I will say VLAN 40. Okay. Now I'll say interface F0/11. Okay. No switch port access VLAN 40. Now 11 will be in the default VLAN. Okay. Likewise, you can remove the switch port. If you want to remove this VLAN 10, then say no VLAN 10. Then the VLAN 10 will be deleted. Likewise, you can create the VLAN and delete the VLAN. How I'm going to put some interface in the trunk port? First of all, before showing this trunk, there is one topic called DTP. Okay, but I will show you this. Exit, show interface F0/1 switch port. Okay, here. Okay, I'll take another switch. Operational mode is down. Excuse me. Okay, I'll come to this part later because if I explain DTP, then you will understand. So this by default, all these ports are in what mode? Access mode only. By default, all the ports are in access mode. How I'll make it into trunk? If I want to make this interface F0/1 as trunk, then what I'll do? Interface F0/1. Okay, switch port mode trunk. That's it. Initially, I said switch port access. Correct? To put it in the VLAN. Now I am saying switch port mode trunk. First, I'm creating a VLAN under VLAN. I'm putting the switch port under one particular VLAN, and then I'm making into trunk. How I'll make into trunk? Interface F0/1 switch port mode trunk. If I want to make this range, interface range F0/2 to 5. Okay, switch port mode trunk. Okay, likewise, you can make from 1 to 24 also trunk, multiple. With one command, every port it will become the trunk port. Okay, write down all the commands. Should I give it, or you gonna watch the recording and you're gonna write it? Which is easy. I'll give you. Okay, VLAN 10 name is sales. Okay, interface F0/1 switch port mode switch port 10. Okay, likewise, another one is range interface range F0/2 to 10. Another one interface range F0/11 comma 0/12 comma F0/13. Excuse me. Written. How do you see the show VLAN diff, and then you have another one how to create the what do you say that, so put it on the switch trunk mode interface F0/1, then switch port mode trunk. Done. What is trunking? So a trunk is a single channel of communication that allows multiple entities at one end to correspond with the correct entity at the other end. It is a link that carries many signals and at the same time creating more efficient network access between two nodes. With VLAN trunking, it is possible to extend a VLAN across the network when you implement multiple VLANs across the network. So trunk links are necessary to ensure that VLAN signals remain properly segregated from each to reach their intended destination. This is called more efficient as multiple VLANs can be configured on a single port. So see, if you are having a okay, so I made this also trunk port and this also trunk port. Both the ports are in trunk port, and here I have connected with multiple devices. Here also multiple devices are connected. Okay, so how they are going to make this into trunk port and send the packets? That means frames through process called trunking. This process is called trunking. So there are two port protocols in this trunking. Okay, one is ISL that we say it as inter switch link. Okay, other one is IEEE 802.1q. This is open standard and this is Cisco proprietary. Okay, but even the Cisco switches are not using this ISL nowadays. Okay, they are not using ISL. We are using only IEEE 80.1Q only. Why? I will tell you. Okay, so what is this trunking? So to send the multiple VLAN information from one switch port to other switch port, we need this trunking. So how it is done? Who is carrying it? Your IEEE 80.1Q protocol. That protocol is responsible for carrying the different VLAN informations. If it's same VLAN, it is not required. But if it's a different VLAN, then you need. Okay. But in your real time, anyway, you need different VLANs. You can't put everybody in the same VLAN. Then what's the use of VLAN concept? We can simply say LAN and go, right? Correct. So every time we are using this ISLN 802.1Q. Write down this ISL. That is inter switch link. And it is a Cisco proprietary. And it is a 30 bytes. All frames are tagged. That is entire. Here you can write it down. Entire then you have IEEE 802.1Q. It is 4 bytes. Write it down. Feels like just now we started the batch, it's already 3 weeks. No? Written? Okay. So, see, this is a Cisco proprietary. Okay, and it has frames of how much? 30 bytes. Okay, so 26 bytes of, okay, 26 bytes, it has its own header, ISL header. So it will be ISL header plus Ethernet frame. Okay, but whereas in IEEE, within the frame, only 4 byte we are including it. So how much extra bytes here? 26 bytes. So totally 30 bytes it is. Totally it is 30 bytes. And this is a 4 byte only. So how much byte extra here? 26 bytes. So that's why we are not preferring this ISL anymore. Even Cisco switches don't use this ISL. They are using IEEE 80.21q. Okay. And here all frames are tagged. It means, see, if there is a VLAN, okay, my switch ports, all 24 ports are in VLAN 10. So that will be called as VLAN, native VLAN. Because only one VLAN it is there, and that VLAN is native VLAN. Okay. Whereas in your IEEE, it will not tag that. If a frame comes without tagging, then the opposite switch will understand this is a native VLAN. Okay, if I have VLAN 10 and 20, okay, and if I'm making only VLAN 10, so for the VLAN 10, then native VLAN it will be given. It will be tagged. But in your switch ISL, even though if there is only one VLAN, still it will be tagged. Whereas that will not happen in your IEEE 80.1q. That is the difference. See, native VLANs are not tagged. Here, native VLANs are tagged. All frames are tagged. Any VLAN, it will be tagged. Whereas in your I1.1q, your native VLANs are not tagged. So tomorrow you have one task. What is native VLAN? What is native VLAN? You have to explain me. Okay. So this is the reason we are using this IEEE. Okay. So what we have seen as of now, what is VLAN? What is the advantages of VLAN? Okay, how to segregate a VLAN? Correct. What is the reason we are segregating? These all things we have seen. After that, we have seen two ports, switch port and access port and trunk port. What is access port and what is trunk port?
Within the same VLAN and support it for
Correct.
transfer the data.
Different VLAN, then we need trunk port. So if we need trunk port and if we need to send the data, then what is required? Trunking required. What are the two protocols in there? ISL and IEEE 80.1q. Okay, what we are using? What is the reason? Because there it is only 4 bytes, there it is 26 bytes extra header is there. Here we are encapsulating inside the frame, but there total header plus frame is there. So that's why we don't use it. ISL. Okay. Now I'm going to teach you one interesting topic. That is your DTP, Dynamic Trunking Protocol. Write down for Dynamic Trunking Protocol. It is a function on a switch, DTP. Write down DTP, Dynamic Trunking Protocol. It is a function on a switch. It is a function on a switch which establish. It is a function on a switch which establish trunk negotiation automatically on neighbor switch. And it is a Cisco proprietary. And it is a Cisco proprietary. So it is a function on a switch which establish trunk negotiation automatically on the neighbor switch. Okay, and it is a Cisco proprietary. And we have 4 modes in DTP. We have 4 modes. First mode we say access, trunk, dynamic auto, and dynamic dynamic desirable. Written. Okay, so 4 modes are there. So what does this DTP mean? See, here I have a topology here. Correct. So in this switch, in this from switch 1 to switch 5, by default, all the ports are in which port? Access port. Okay. So here I have two PCs connected. Here also I have two PCs connected. So this is VLAN 10, 20, 10, 20. So between 10 and 10, it will communicate because it is in the same VLAN. But from 10 to 20, it will communicate? No. Then what should I do? I have to make it into trunk port. Which ports I will make into trunk port? This F0/1 and this F0/1. Correct? Because this is how the data will be went through outside the switch. So these two processes I will make is trunk. Correct? Now what is this DTP? It automatically makes the trunking negotiation. So one side if I make it as trunk, other side automatically it will become as trunk. So both are access. I don't have to go and change trunk here also, here also. This side I will make it as trunk, the other side it will automatically become trunk. But within the link, that is important point, within the link only. So if I make trunk here, this side will not become trunk. Whatever it is directly connected, the other side will become trunk. So if for example, if there is a switch here, this F0/2, if I make trunk, F0/1 automatically will become trunk. But this F0/2 will become no. Likewise, this F0/1 will become no. Only the directly connected will automatically become trunk negotiation. For this purpose, we are using this dynamic trunking protocol. Okay. So in this dynamic trunking protocol, we have 4 modes. Like I said, we have access, trunk. What is access? Same thing, that is within the same VLAN only. What is trunk? Different VLANs. Okay. Trunking negotiation will happen. If one side is trunk, automatically other side will become trunk and the trunking negotiation will happen. Correct? If one side is access, other side is access, will the trunking negotiation happen? No. Because the DTP will not work because both sides are access. One side is trunk, then the other side will become also trunk. This is fine. We have this dynamic auto. Correct? And we have dynamic desirable. What is this dynamic auto means? It is passively waits for trunking negotiation. Okay, this is your dynamic auto. What is dynamic desirable? It initiates trunking negotiation. This is your dynamic desirable. Okay, if there are two switches like this. Okay, so initially here it will be in auto mode. Here also it will be in auto mode. What is this as auto mode means? It passively waits for trunking negotiation. That means he is ready for trunking negotiation. Both the end are ready for trunking negotiation, but they're not initializing the process. Okay, he is saying, okay, let him say hi, then I will say hi. The other side also saying, okay, let him say hi, then I will say hi. I'm ready to say hi, but I will not say hi. Ego problem. Correct? So, same problem this auto mode also has. But what is this desirable? He will say hi, like boys. Every time we have to. Understood? Yes. So, desirable will say hi. And automatically he will ready for the trunking negotiation and the trunking will happen. This is your auto and desirable mode. They will ask you in interview. Explain DTP. What are the modes in DTP? What is the difference between auto mode and desirable mode? Okay. Then what is this auto mode and desirable? Auto mode is it passively waits for the trunking negotiation. Okay. And desirable mode, Dinesh, what are you doing?
I'm thinking about that.
Thinking about what? Hi.
At the end desirable.
You said so many eyes, huh? Oh. So desirable mode, it will initiate the trunking negotiation. Okay. Any doubt on this? Now come to PPT. I'll show in practicals also. First, we'll finish off this theory. So this is your ISL IEEE. Then you have this DTP. Someone read this, Siri. Little louder.
Ethernet trunk interfaces supports various trunking modes. Those interfaces can
No,
be
from here.
DTP Dynamic Trunking Protocol is a trunking protocol that is developed and proprietary to Cisco, which is used to automatically negotiate trunks between Cisco switches. Trunk negotiations are managed by DTP only if the port is directly connected to each other.
So what is this point they've explained? They said it is used to automatically create the trunking negotiation, and then it is only if it's directly connected on the Cisco switches. Okay. Next point.
Ethernet trunk interfaces support various trunking modes. Those interfaces can be configured as a trunk or non-trunk.
Wait. So those interfaces can be configured as trunk or non-trunk. What is trunk port means? Trunk. Non-trunk means access. Very good. Okay.
How to initiate negotiating trunking to a neighbor interface or is waiting to receive a trunking negotiation message from.
Wait. What is this initiate negotiating trunking? It is your dynamic desirable. And here it is waiting to receive a message, that is your auto. Correct. Okay. Next, most Cisco switches nowadays use IEEE as their trunking type of choice because of less overhead compared to ISL. Okay. Now is it clear? Okay. Now switch port mode access. Okay. Will I read?
Switch port modes access.
Mhm.
An access port does not act as a trunk interface and only allows one VLAN through that port.
Correct.
An interface in access mode become a non-trunk interface.
Mhm. Regardless of
Regardless of whether the neighboring interface is a trunk interface.
Correct. That means one side is trunk. Okay. He is sending a VLAN 10, 20, 30, 40, 50. But this side it is access only. Then what is the point? Because he will not accept all the VLANs. He is going to accept only the one VLAN. Correct. So that's why, regardless whether the neighbor interfacing is trunk interface or not, that mode will be in access mode only. Okay. You read next point, switch port mode trunk.
Switch port mode, the trunk mode enables the interface to be set in permanent trunking mode and establishes negotiations to convert the neighboring link to become a trunk link. Though the switch interface becomes a trunk, even if the neighbor interface is not.
Correct. So one side what we are making, if we are in auto mode, both the sides are in auto mode only. So if I make it as permanent trunk mode, then automatically the other side also will become trunking negotiation will happen. The mode will be in auto mode, but the trunking will definitely happen. That is your trunk mode. Okay, because we are permanently putting that interface into a trunk mode. Okay. Then you have dynamic switch port mode, dynamic auto. Mohammed.
This DTP mode makes the interface passively waits to receive a negotiation message to make itself a trunk.
Mhm.
At which point the switch will respond and negotiate whether to use trunking.
Mhm.
The switch interface becomes a trunk port if the neighboring interface is set to trunk or dynamic reserve mode.
Correct. So what the only key points are only these words. It passively waits. Okay. And only it will become a trunk port if it's a trunk or dynamic desirable mode. Why? Because it is waiting. If I put it on the trunk mode, then what will happen? Permanent trunk, the opposite side also will become trunk. If I say dynamic desirable also, it will initialize the trunking negotiation and the trunking will happen. Only if it will not work if it is in access mode. It is passively waiting for trunking negotiation. What is desirable? It initiates trunking negotiation. Initiates trunking, and even if the opposite side is trunk mode, desirable mode, and auto mode. it will work. Okay. Now we are going to see the practicals of all 4 modes. Okay, then it will become very clear. Okay. CCNA level interviews, they will ask this DTPs. Okay. So, did I make this trunk mode? Yeah, I made it trunk. I'll delete this. Okay. See, this is my switch 2. F0/2 is connected here. What is the administrative mode here? Dynamic auto. By default, it is in dynamic auto only. Likewise, operational mode is in what mode? Static access. Why it is in static access? Tell me.
By default, it will
No.
passively waiting for it.
See, one side it is in auto. The other side is also auto. So both are waiting for trunking negotiation, but trunking negotiation was not happened yet. So that's why it is in static access. See this mode. Go to switch 3. Show interface F0/1 switch port. See, this is also in dynamic auto and static access. Now I'll make this port as what mode? Trunk mode. Interface F0/1. Switch port mode trunk. Done. Now see, what is the operational mode? Trunk. Initially it was static access. Now it is trunk. What is the operation active administrative mode? Trunk. What is it is using? .1Q. Now go to switch 2. It will take some time. See, mode is auto, but operational mode has become trunk. How it has become trunk? Because of this DTP protocol. Did I make anything on this interface? No. But from static access, it has become trunk here. Now, this F0/2 is in access. F0/1 is also in access. Go to F0/2 and say interface F0/2. Okay. Switch port mode dynamic desirable. Okay. Show interface F0/1 switch port. Operational mode has become trunk. F0/2, right? Mode is in dynamic desirable and operational mode is trunk. Will the opposite form the trunk or not? It will form. Why? There it is DT, I mean auto, here it is desirable. He has initialized the trunking negotiation and now in this F0/1 it will be trunk. Show interface F0/1 switch port. Operational mode is in trunk. Okay. So this side it has become trunk, here also trunk, here also trunk, here also trunk. Correct? What about these two? This is also in auto, this is also in auto. So what either in this switch or this switch I have to make it into dynamic desirable or trunk. Okay, I'll go to this switch. Enable. So interface F0/1. I'll say switch port mode dynamic desirable. Done. Now go to the switch and check F0/2. Trunk. So trunking negotiation is there completely. Okay. Now, I have this table in this PPT. This one table is enough to understand your DTP very clearly. So this is one switch. Here we have another switch. Okay. Switch 1, switch 2. So with dynamic desirable and dynamic desirable, trunking will happen. Desirable to auto, trunk will happen. Because he is sending high. He is sending high. He waits. This is trunk and this is access completely. Okay. So high, he will say return back high. So trunk. So trunk and desirable, it will happen, trunk. But anything with the access, it will not happen. See, if the one side of the switch is in access, the other side is in any other mode, that is auto, desirable, trunk, it doesn't matter. Then the port will be in access only. Because access, static access will carry only one VLAN information. It will not form trunking. So anything on the access, it will be access. Easy. Likewise, in this side of the switch, if it is access, everything is access. Okay. And see, other than everything, if it's auto, it is access. Because both are waiting to say hi. Both are waiting to say hi, that's why it is access. Other than that, everything is trunk. In simple, you can remember, okay, if one side of the switches is going to be access, no matter what, any other mode it is in the other side, it will become access only. Okay, that one point is clear. Another point, between auto and auto, it is access. If you check anything else, it will be in trunk mode only. These two key points, this table you can understand. If one side of the switch is in access, then it is a completely access mode only, static access. And if both the sides are in auto, again it is in access mode. Simple. Okay, this is your dynamic trunking protocol. Any doubt? Remote. Online guys? Offline? Clear? You want to note down this table? Yeah, note it down quickly. No, clear. Very good. Write it down.
Sir, just a doubt on one thing. Like, is it possible for us to connect two switch
Mm-hmm.
to access port,
Mm-hmm.
but then add more than one VLAN to that access port? Like, the interfaces can, like, the same interface come
Yeah,
under two.
I understand your doubt. Wait, I'll show you. Your question is like this, right? So if there is a switch like this, and there's another switch here, you're asking I can create multiple VLANs. Yes, you can create 10, 20, 30, and 40 here also. Here also you can create 10, 20, 30, and 40 also. That you can create. But 10 can only communicate to 10, 20 can only communicate to 20. If you want to communicate from 10 to 20, then you need trunk.
Trunk.
Is it clear, Prashant?
Yeah, thank you, sir.
Okay.
VLAN can be created in.
As much as this is there. Range. Within the range, you can create as much as you want.
When we get different VLANs, we need
Yes.
4094.
Yes, not 4094 because and we don't create that many VLANs in one switch. In your enterprise level, you will have multiple switches. I'll show you how a design will be, I mean, how the topology will be created in your, organizations. You will have multiple switches, not one or two switches connected. Okay, and links also, they will be connected with 8, 9 links with between two switches. Up to 16 links also you can connect. So they are not going to create all the VLANs in one switch. That will become too much traffic in one switch. So they'll segregate the switches. Okay. All right. So this is your DTP. Now we are going to learn VTP. VLAN Trunking Protocol. Visible, right? Too. Okay. So what is this VLAN Trunking Protocol? Just write one line for VLAN Trunking Protocol. VTP. It is used to synchronize the VLAN to other switches. Okay. Okay. I'll explain you here. See, this is just like your NTP. Yesterday we have seen NTP. What we did? Synchronizing the clock. Here we are synchronizing the VLANs. So in one router, what I did? I changed the clock, and other two routers has got the same time from that particular router. That is called NTP protocol for time synchronization. Here we are using it for VLAN synchronization. So one switch I'm going to create the VLAN, so all the other switch will get the VLANs like that. But some kind of differentiation is there that I'll show you. Here you are having 3 modes. Okay, you have server, you have transparent, and you have client. Okay, 3 things. So in server, you can create, delete, add, or edit VLANs. Okay, you can create, edit, delete, or add the VLANs in your server mode. And whatever you create in server mode, that will come to your client mode. Okay, so but here you can't create, delete, edit, or add any VLAN. That is not possible in your client mode. But whatever you create in server, that will come to your client mode, just like your NTP. Okay, this is clear. But we have one more mode, important mode, that is your transparent mode. What is this transparent mode means? What is this transparent mode? This is something like your server mode. Here you can create, delete, edit, and add VLAN. Okay, but whatever you create, listen to this point and then you can write it down. See, whatever you create in server mode, okay, that will be synchronized with only client. It is not going to be synchronized with transparent. It will remain like a separate, you can say separate database. Okay, it's like a separate database. Whatever you create in transparent will remain in only transparent. It is not going to synchronize with server, either client. Likewise, whatever you create in server, that will be synchronized with client only. It will not synchronize with transparent. For example, here I'm saying 1020. So that 1020 will come here. It will not go to this transparent. If I'm saying here 30 and 40 in transparent, it will stay only in transparent mode. It is not going to be done in your server or client mode. Okay. So this is your server transparent client mode. So what this transparent mode will do, it will advertise the VLAN information. Like for example, if I'm having a switch like this, here I'm having server switch. Then I'm connected with transparent switch. Then I'm connected with client switch. So he will advertise all the informations, all VLAN informations he will advertise to client, but he will not synchronize it. That is one point. Okay. Now come to your PPT. So VTP is a Cisco proprietary protocol used to maintain consistency throughout the networks, and it is used to synchronize the VLAN information under same VTP domain. So VTP allows to add, delete, and rename VLANs in there propagated to other switches in VTP domain. So VTP advertisements can be sent over 1.1q trunking link or ISL trunking links. Okay. So we have multiple VLANs. So VLANs will be carried through your trunking protocol. Requirements are VTP version should be same on every switch. Okay. And then it should be configured under same VTP domain. And also switch must be in respective modes. One switch must be also a server mode. Okay. By default, your switches, every switches are in server mode. By default. We are going to change it into transparent and client mode. Okay. Okay. I will do this practical and then we'll come to this PPT. Okay. So here I will make this switch as server. This is transparent. This is client 1. This is client 2. Okay. Okay. So show VTP. Show VTP status. What is it mode? Server mode. Correct. So already the mode is in server. Now I'll change the version. VTP version is, I will say 2. Okay. VTP mode is done. Next VTP domain. I will say cisco.com. Cisco.com. Okay. Now go to transparent. I'll say host name transparent. Okay. So first I'll say VTP version is 2. Okay. And then VTP mode is transparent. Okay. VTP domain name cisco.com. Done. Go to your client. Client 1. Okay. VTP version 2. VTP mode client. Okay. And then we have VTP domain. What is the domain? Cisco.com. Done. Go to client 2. VTP version 2. VTP mode client. VTP domain Cisco.com. Everything is done. No, but now all the links are already in trunk. I made it trunk while doing the DTP practicals. So from this side to this side, everything is in trunk only. See, while you're doing in different times, make sure you make all the links as trunk link. Okay. Now what I'll do show do show VLAN brief. Is there any VLAN created? No. I'll say VLAN 10 and VLAN 20. I've created two VLANs. Do show VLAN brief, and you can see VLAN 10 and 20. I'll say VLAN 10 name HR. VLAN 10 is HR now. Go to your client. Do show VLAN brief. So 10 and 20 are there. 10 and 20 are there. Go to transparent. Should be there or not? It will not be there because it is a separate local database. It will just forward the VTP advertisement, but it will not synchronize with the VLAN. So here what I will do, I'll say VLAN 30 and I'll create VLAN 40. Okay. 30 and 40 are there, but that 30 and 40 will not be here and will not be here also. Okay. Whatever you create in transparent mode will be set only in transparent mode only. Okay. Any doubt on this? So this is your VTP. Okay. One more thing is there in VTP. Wait, I'll show you. There is one small problem. The phase F, first I'll say VTP version 2, VTP mode, VTP domain, cisco.com. Okay, server is in server. Okay, all good. Interface F0/1, switch port mode, trunk. Okay, so here I will do what I'll do. I'm going to create some VLANs. VLAN, I'll say 11, 12, 13, 14, 15. Okay, no VLAN 11, 12, 13, 14, 15. Okay. So this is my organization switch. Okay. So here I will do, what are the VLANs here? 10 and 20 are there already. Go to this switch and say do show VLAN brief. Is there any VLAN here? No. So this is my organization running. If I'm suddenly bringing one switch and inserting, okay, I'm going to connect it with my other switches. Then what will happen? And that switch is in same VTP domain. Okay, same VTP version. And also it is in server mode. What happens if two server modes are in same switch, same topology? See, I'm going to connect it with this transparent. Okay, so this F0/1, what I made? Trunk. So this side automatically it will become trunk, correct? I'll fast forward. Okay, now go to this client. Do show VLAN brief. Do you see any VLAN here? All the VLANs are deleted. Imagine if you're having 100 VLANs and I'm bringing a new switch to the topology and I'm going to connect it. Hemant is keeping like this. Cold, okay. See this server? Is there any VLAN? No. Why? Because it has taken this switch as the server. Because already this server, this switch is in same VTP domain, same VTP name also. I mean version also. Now, why it has taken this? Because if you go and check here, do show VTP status. Here revision number is 10. Correct. Initially the revision number was not 10. Zero. Initially revision number was 0. But now it is 10. When this revision number will increase, see, check this one. Do show VTP status. What is the revision number here? 10. So for example, I am going to say VLAN 22. I've created a VLAN. Now see the revision number 11. Now this will be in the switch also. Do show VLAN brief. 22 is created here. So it will take which switch has the highest revision number. So for example, if there are more configurations in the switch, okay, and I've deleted all the configurations, but the revision number will be high only. So if this switch comes into the topology, this switch will be taken it as the server. So it will synchronize with all the switches and every configuration will go. Okay, to avoid that, what we have to do, whenever you are inserting a switch into the topology, you have to make it to transparent mode. Make it to VTP mode transparent and then connect it. And then you can make it to according to your requirement. Either you keep it in transparent or client or whatever you want. This is the recommended way. Okay. Any doubt on this? Online guys? Okay. So just you can write down these comments. VTP version 2, VTP mode client, and then VTP domain cisco.com. And to check it, check the VTP. What is it? Show VTP status. Write it down. Written guys. Show VTP status. Next point, write down. Show VTP status. Written. So what we have seen today, VLAN Trunking Protocol, access port, trunk port, DTP, VTP. So we'll finish here because next topic, if I start, it will become very difficult for you. That is STP. I don't want that start that. Okay. See, switching all small topics. Okay. All small topics. So, and a lot of theory also there. You have to go through it. Then only you will keep remembering it. Okay. Monday we'll see STP. Very interesting. Okay. I'll teach you STP. Usually STP, as of CCNA level, it is a very small topic. Okay. But I will make it more complex and I will teach you. That makes sense. You will understand it more clearly. So I'll take multiple switches, multiple links, and I'll make sure you will understand each and everything. Okay. Because STP is something people get mainly trouble in interview and also in practicals. Understanding purpose is very important in STP. So that we'll see on Monday. Okay. So Monday we'll see STP, and if possible, we'll see Ether channel also. And then we have one small few topics. We'll finish it off by Tuesday. So we have Wednesday, Thursday, Friday. And one extra class either on Saturday or Sunday. CCNA is done. Okay. I'm not going to skip any topics. Don't worry. Complete topics I will take. Even extra topics I'll take. Okay. So that will be done. So next 2 days you have off. At least finish all the practicals of switching. Don't leave it. And I'm not exactly sure if I'm going to start CCNP switching or not batch. It's not been scheduled yet. Okay. There is a chance I might start on 21st of this month. If not, you can join with other trainers. Okay, that's up to you. All right. So today I'll finish the meeting here. Thank you.